Hi everyone, so in this video we're going to work through a Year 12 pure maths question from the AS 2018 paper on differentiation by first principles. The question says prove from first principles that the derivative of x cubed is 3x squared. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level Maths topics that will come up in your 2027 exams. So now that the 2026 exams have finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018 and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up. Sign up to the app and you'll be able to access all of these 2027 predictions. Now, to do differentiation by first principles, of course, we need to use the formula, which is given to you in the formula book. But the formula is this: the derivative of a function is the limit as h tends to 0 of f of x plus h, subtract f of x, and then divide by h. Now, in this case, the function we're trying to differentiate is x cubed. So therefore, we can let f of x equal x cubed. So therefore, this means if the argument of the function is x plus h, then f of x plus h must be x plus h all cubed. So therefore, the derivative f dash of x will be again the limit as h tends to 0 of f of x plus h, so x cubed, or x plus h cubed, I should say, and then subtract x cubed, divide by h. So we're just going to simplify the top of our fraction. So the limit as h goes to 0. Don't forget to write that at the front. That is very important. So expanding the brackets, this gives us x cubed plus 3x squared h plus 3x h squared, and then plus h cubed. And then we subtract the x cubed, divide by h. Now, if you're wondering how I was quickly able to just expand the brackets there, I used binomial expansion. If you're not comfortable with binomial expansion, then obviously, get some more practice with that and revise that topic. But if you're comfortable with binomial expansion, expanding x plus h cubed should not be too difficult for you. Just another quick interjection. If you are currently doing Edexcel A-level Maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Now then, we can actually cancel out the x cubes. So just cancel out the x cubes there. So this is the limit as h tends to 0 of 3x squared h plus 3x h squared, and then plus h cubed over h. So now what we can do is factorize an h out on the top. So the key idea with these differentiation by first principles questions, we want to factorize an h on the top so that it can cancel out with the h on the bottom. And then once we get rid of that h on the bottom, it then becomes easier to apply the limit of h going to 0. So let's do that now. So in the brackets, 3x squared plus 3xh plus an h squared, close brackets, and then divide by h. And now we can cancel out the h there and there. Now then, we can write that this is the limit as h goes to 0 of 3x squared plus 3xh plus h squared, like so. Now, as h gets closer and closer to 0, well, this middle term there is just going to go to 0 because 3x times 0 virtually is 0. Same with this last term, this h squared. If h goes to 0, then h squared will tend to 0 as well. So this tends to 0. So what happens now is we're just left with literally 3x squared, and that's our derivative there. There is obviously no h in that term there, so this just literally tends to 3x squared like so. So our final answer is 3x squared. So therefore we have proved the derivative of x cubed is 3x squared. If you do have any questions, do drop a comment below, but hopefully that process we've gone through does make sense.